preparation of ethers. Ethers are compounds in which oxygen is bonded to two alkyl groups or two aryl groups. Okay, this may be alkyl group, or this may be aryl groups, or this may be one alkyl or one aryl group. Such compounds are called as ethers. Okay, different methods of preparation. First method is dehydration of alcohols. Dehydration of alcohols. The reaction takes place in presence of protic acids like H2SO4, sulfuric acid, or H3PO4. Okay. Phosphoric acid. Reaction takes place in presence of any of these two acids. Okay. And on alcohol on heating at a temperature of 413 Kelvin, reaction takes place. Okay. Reaction is as follows. 2C2H5OH on heating with concentrated H2SO4, the temperature will be 413 Kelvin. The product obtained will be diethyl ether. Diethyl ether. If the temperature is raised from 413 to 443 Kelvin, the product obtained will be an alkene. Okay, concentrated H2SO4 and the temperature is 443 Kelvin. Product will be CH2 double bond CH2. Okay, plus H2. Alkene will be obtained. Okay. Now, different steps for the mechanism of this reaction. That is the reaction, the mechanism here is SN2 mechanism. The formation of ether, the mechanism is SN2 mechanism. Different steps for SN2 mechanism are: first step, formation of protonated alcohol. First step, formation of protonated alcohol. So CH3 CH2OH plus H plus gives CH3 CH2O plus H. Okay, like this. This is the first step. And second step is this protonated alcohol reacts with another molecule of alcohol. Product will be like this: CH3 CH2 OH plus CH2 CH3 plus H2. This is the second step. Now, next step, the H plus ion proton will be removed. Okay, H plus will be removed and form ether. CH2 CH3. Product obtained will be like this: CH2O CH2 CH3. Okay, so diethyl ether will be obtained. This is the different steps involved is in the SN2 mechanism. Okay, this method is more suitable for primary alkyl groups. Okay, this method SN2 mechanism easily takes place for compounds which are having primary alkyl groups. Okay. If secondary or tertiary alkyl groups are present, reaction takes place through SN1 mechanism. Okay, so what will happen? Alkenes are obtained. In the case of secondary or tertiary, alkenes are obtained. Okay, so always we prefer primary alkyl groups for this process, for this method of preparation. Okay, this method is also suitable for is not suitable for unsymmetrical ethers. Okay, not suitable for unsymmetrical, for the preparation of unsymmetrical ethers. this process is impossible. Okay, this process is not suitable. Okay. Next method of preparation, Williamson synthesis. So, this method is used for preparing both symmetrical and unsymmetrical ethers. Okay. So, in this method, the reaction takes place sodium alkoxide on heated with alkyl halide. Either will be obtained. Okay. So, either can be obtained from sodium alkoxide and alkyl halide. This process is known as Williamson's synthesis. Okay. The reaction will be Rx plus RONA, sodium alkoxide. Reaction takes place and the product obtained will be ROR, ether will be obtained, plus NaX. Let's take one example. CH3ONa plus sodium alkoxide, alkyl group is CH3 groups, plus CH3Br. On reaction and heating, okay, it gives CH3OCH3 plus NaBr. We can also use C2H5, ethyl bromide. We will get an unsymmetrical either CH3O, C2H5 will be obtained. Okay. Now, if we have to prepare an alkyl aryl ether, how can we prepare alkyl aryl ether? We know that if an halogen is attached to a benzene ring, it is non-reactive. Okay. If an halogen atom is attached to a benzene ring, it is highly non-reactive. So what will happen? So in order to prepare an alkyl aryl ether, first we have to take a mixture of sodium phenoxide and alkyl halide. Okay. So, we have to use sodium phenoxide for the preparation of an alkyl aryl ether. Okay. So, how can we prepare this? First, let us take phenol. Okay. Phenol on reaction with sodium hydroxide, we will get sodium phenoxide. Okay. ON, sodium phenoxide. This is sodium phenoxide. Sodium phenoxide on reaction with an alkyl halide, Rx. Okay, Rx. Product obtained will be an ether. Okay, OR plus NaX. So, like this, the reaction takes place. Okay. Now, next one. Next point. Primary halides gives better results than secondary and tertiary halides. Okay. So, alkyl group, the alkyl halide, in the case, while we are choosing alkyl halide, it must be always an primary alkyl halide. When we are using a tertiary alkyl halide, what will happen? We will obtain an alkene. Just take one example. If we are taking a tertiary alkyl group like this, tertiary halide, if we are using a tertiary halide, okay, CH3ONa, okay, if we are using alkoxide and tertiary group, tertiary alkyl halide, what will happen? The product obtained, this is a strong base, okay, so the product obtained will be CH3C, CH3 double bond CH2 and alkene will be obtained. Okay. And plus NaBr plus CH3OH. Okay. Like this the reaction takes place. So in order to obtain an ether, we have to use a tertiary group, and either containing a tertiary group, we have to use what we have to use? We have to use primary halide and tertiary alkoxide. Okay. So, like this. CH3, CH3ONA. Okay, this is a tertiary alkoxide. Okay, plus CH3Br. The product obtained will be an ether. CH3, CH3, OCH3 plus NaBr. Okay. So from this we can see that always primary halides gives better results in this reaction.